Well, we'll get started, guys, for the sake of time, keeping for those of you joining, there'll be people continuously joining. Thanks for hopping on today. Want to take a second to let you know who I am. My name is Steve Stewart. A lot of you know who I am. I founded this group with a friend of mine back in 2016, and I believe this is now the 44th user group that we've hosted since then. And a lot of you guys have been here and help support us and throughout the year. So thank you for that. We do have a few more that we already have planned for the remainder of the summer. We're going to continue to have them virtually for the foreseeable future until we start feeling more comfortable meeting in person. So be expecting at least through August for a couple of them to be, a lot of them be virtual, as well as one coming up in July that we're putting on the map now, putting together is a local, don't want to put too much information out there until we get all the stuff ironed out, but one of the local organizations, companies in Nashville are going to be sharing a bit of their journey, their personal journey over the last 3 or 4 years to get where they are today. And it's a company all you guys know and love and probably have worked for or work for now currently. So, you know, I think it's great to hear how people have done these things, but it's even better to hear, you know, one of our own, their experience here in Nashville and share and give you guys chances for Q&As for them as well. So that'll be coming up in July. We'll put the announcement out here in the next week or so. But I don't need to show you guys where the bathrooms are or anything. I think you guys know where they're at, hopefully. But I have my friends from JFrog here. I'm going to turn it over to them in a second. I will say we're going to have some time for them to talk through the topic at hand. But this is going to be interactive, so if you guys have any questions at all throughout the process, feel free to light up the chat window. I think by now you guys know where that is in Zoom. I'm sure we're all zoomed out at this point. So feel free to, and if we'll be monitoring that, so you can jump in and we'll have some Q&A at the end. But this is being recorded, so if you you know, afterward we'll send out the recording so you can rewatch it and share it with coworkers and friends as well. So with that, with no further to do, I'll turn it over to Ari. And Ari, I'll let you introduce yourself and kick things off.
Okay, great. Well, thanks again, Steve, for organizing this. And I have family in Nashville, love the city, so it really means a lot to be with you, even in this way today. I'm going to show a slide in just a moment, but just a little introduction to JFrog. At a DevOps meetup, I think that most people have heard of JFrog, and they have, you know, and if you haven't heard of JFrog, you probably have heard of our flagship product, Artifactory. It's been around since really in OSS form back in 2006, even before the company started in 2008. So just really, really excited to you know, just be part of your community today. And we're going to do a couple fun things today I want to make you aware of. You know, Baruch's going to point to you to a website where you can catch the slides and eventually the video and everything, and he'll make reference to that. But we also have a really couple cool raffles. One of them is we're going to give out 3 JFrog t-shirts today, which will be Iron Frog. So if you haven't seen that one yet, Julie, you're going to like Iron Frog. So you should join that one. It's really one of our cooler t-shirts. So we'll give 3 of those out today if you join the raffle on that page. But also there's a monthly drawing, which you'll see when you get there for Nintendo, for 2 Nintendo Switch Lites with Animal Crossing games. We do drawings from all of our meetups at the end of June. So just a little quarantine cheer for everybody that we like to spread around. The one thing I want to do, can you just show, let me see, can you disable, or can you enable me to share my screen really quick, Steve? I'm sorry. Just want to show this slide real quick. I think if you go to participants, I think if you make me one of the co-hosts, I can do it. Okay, cool. Yeah, just one screen I wanted to share with you is every year we have our Swamp Up conference. But we have this year there's a day that's open. Really, it's open for a lot of amazing talks. As you can see, we have the founder of Jenkins that'll be there. John Willis will be there. Jessica Dean. So we've got some really great speakers that day. All the proceeds from the conference are actually going to be donated. But at the same time, we wanted to give out 5 free tickets to your meetup today. I'm going to put that code in the chat box shortly. If you want to register, please do. It's going to be good for 5 uses. I'll tell you, if you're not one of the 5, the tickets are only $20. And again, it's going towards COVID-19, which is a great cause. And I don't know, it's $6 a talk to hear these folks, at least, even if it was just them. I think it's a pretty good deal. Last but not least, as it relates to that, is even if you do get a free ticket, you're not taking anything away from COVID, because when you do get a free ticket and you do come, JFrog does put that $20 donation in on your behalf. So wanted to make sure you're aware of that as well. So anyway, I get all the fun stuff. Now you get to hear the fun speaker. And I really appreciate allowing us into your community today. And I'll put that code in just a few moments. Thank you.
Thank you, Ari. And yeah, so everybody are going to register to SwampUp instead of listening to me. Good job.
They'll wait. I'm sure they'll wait.
All right. So with that, while you registered, Steve, if you can give me the sharing permissions, I will go ahead and start.
I believe I handed off to Ari. So.
Yeah, Ari is the host now. I hope he didn't leave.
Let's see. I'm here.
Yeah. So either.
I'm going to. I'm the host. Let me move this over.
You're the host. Look at you. And all you had to do is give 5 free tickets.
There you go.
All right.
Let me see if I can do it. Okay. Oh yeah, here you go. You're on.
All right, it works. This is great. Okay, so hopefully you can see my slides now. Can you?
Yes.
Perfect. All right, let's roll. So yeah, today we're going to talk about continuous software updates and how to do them, and mostly how not to do them. And let's just start. So first, before we talk about patterns and AntiPatterns, I would love to ask ourselves a question: why at all we update software? Obviously, there is some software that don't need to be updated at all. So BC, I'm sure you know, it's a command line like shell calculator that it's not being updated very frequently. It was updated 20 years ago last time for a good reason. The bash doesn't change. Basic rules of math don't change. So why? There is nothing to update. I mean, they had a period when they updated almost every year. I don't know why, but for the last 20 years, they didn't, for a good reason. There is nothing to update. Now, obviously, most of the software is not like that. And most of the software is not like that because it's driven by users, and the users want more features. There are no more features to add to a command line calculator. There are tons of features to add to everything else, right? And obviously, they want those features as fast as possible. They want them, as they say, yesterday or now. And we can see how this drive for features actually accelerates our the updates that provide the features. And I think one of the great examples is the market of mobile phones. You can remember in the late 90s, you had your Nokia or Motorola that you really couldn't do anything with it in terms of updates. You couldn't have installed new software. You couldn't get this software updated. If you have a phone without the snake game, that's all. You have a phone without the snake game. If you want a snake game, what you need to do is go ahead and buy a new phone. And there was, like, you remember this data cable that you could connect, but again, it wasn't even for software updates. It was for like backing up your contacts. So next time you wanted to, you buy a phone with a snake, you could actually transfer your contacts. Not really useful. And then obviously everything changed with the iPhone in 2007. And since then, software updates in our phones is something that we live with. And again, the speed of the software updates only accelerates because we demand more features now. And it accelerates so much that actually even asking us about those updates don't make sense anymore. Unless you want to press, okay, I want to update a couple of times a day for all your apps, you just don't care. It's getting updated automatically. All you see is boom, you have more features now, which is cool. So this is one drive, and this is a very strong drive. The other very strong drive is security. So obviously now every company is a software company, and it means that security vulnerabilities are as important as any other major catastrophe in the world. And the way we can think about battling security vulnerabilities is a little bit like you think about stopping distance when you get your driving license and you learn about cars. There are two completely different concepts that come into play when we talk about stopping distance. It's the thinking distance and the braking distance. They're completely different. Thinking distance is about, you see the obstacle, the light hits your retina, there are electrons firing in your brain, all the way to you press on the brakes. This is the thinking distance. And then the braking distance is the alloys of the braking pads, the materials of the wheel, the materials of the road, the friction between them, all this kind of stuff. Two completely different concepts. Shortening stopping distances is about improving them both. You improve braking distance by better alloys, better roads, better wheels, and you improve your thinking distance just by replacing slow humans with fast robots. This is what you do. Now, battling security vulnerabilities is a lot like that, in terms that there are three very different steps, but in the end of the day, only a combination of three of them can provide fast response. You need to identify that you have been breached, you need to fix the breach, and then you need to be able to deploy the update to production as fast as possible. And here are a couple of examples of how failing to do one of them fast actually caused troubles. This is from 3 years ago. UK hospital system was completely down because of ransomware, and that's because they didn't update a dependency. Their dependency was operating system, because they ran Windows XP that was not supported, and the patch for the ransomware was not released for Windows XP, so they failed to update the dependency, and they paid a very, very high price for that. Very different, but interestingly, the same happened with Equifax, right? And you remember that also almost 3 years ago by now. They failed to update dependency. In their case, it was the Struts component, which was a part of their UI framework. And again, they failed to update it for 2 months. And after they realized that they have a problem, it took them another 2 months to actually roll out an update that contains this vulnerability. And one of the reasons it took them 2 months, not because they're lazy, not because they're incompetent, not because they wanted to do something evil, but just because they don't know how to update software. They never had to. They are oligopoly, they don't have competitors, they don't care about their websites being up to date. They thought they didn't need fast updates. And then it turned out they did, but it was too late. And whatever happened, happened. And the problem is not only we want to be proactive and solve the problems before they happen, sometimes it's not even possible. You can think about Spectre and Meltdown, and if you read about them, you will discover they're impossible to defeat. It means they are impossible to prevent. The only way to fight vulnerabilities like Spectre is being able to react as fast as possible, and reacting as fast as possible means all three of them: identifying as fast as possible, fixing them as fast as possible, and deploying, updating as fast as possible. So you can see there are two very, very significant drives for software updates: the customer satisfaction and security. And you can see how those two drives actually change the landscape in, for example, the State of DevOps report. That's the last one published. I hope we will have a new one very soon, but at the moment we're looking at the last one available, the 2019, and we can see that obviously it's a very significant research, scientific research in our domain. More than 30,000 survey responses. You can see how 20%, every fifth organization, and that's a huge number, of our industry turned out to be the elite performers. And what does it mean, elite performance? One of the things it means deploy multiple deploys per day. And that actually means that we can deliver software, both new features and security patches, faster than our competitors, and possibly faster than people that want to take to abuse a vulnerability. And the reason why there are so many organizations, and if you take 30,000, 20% of them, it's like 6,000 organizations already doing that, that's because it's not a new idea. This idea goes back to at least extreme programming, 1998, that more than 20 years ago, and then reinforced in Scrum methodology and in Toyota production system, or lean manufacturing if you wish, and then in Kanban. It's all about the same. It's about shorter cycle. It's about releasing and updating faster. So with that, my name is Baruch Sadogursky. I'm the Chief Sticker Officer at JFrog. By now, you know, we have tons of fun frogs. We make stickers from each and every one of them. So it's very fun position to be Chief Sticker Officer. Also, another fun position is being head of DevOps and developer advocacy, and actually coming to your meetup, hopefully next time in person. The most important part of this slide is my Twitter handle at JBaruch. Follow me and let's talk there. If you are still not 100% sure, it is conveniently on the bottom of every slide. California disclaimer: the most emotionally expressive and confrontational people, according to the amazing culture map book by Erin Meyer, are from Russia and Israel. I managed to be from both. So if I don't offend you during today's talk, that's my fault. And you can get a dose of that on Twitter, as I mentioned, at JBaruch at your service. The most important slide of today's talk is jeffrog.com/show notes. You go there, you will already find the slide being there. The video, as Steve mentioned, is being recorded, so hopefully he will share it with me and I will be able to refer the video always there. But the most important is all the links to everything I speak about. I mentioned the 2 security incidents. They are on the show note page. I mentioned the State of DevOps report. It's on the show note page. Even the culture map book that I just mentioned by Erin Meyer, it's also there. The place to comment, for ratings, and if you didn't have enough raffles for today, and I'm referring to the free tickets to Swamp Up, there is more raffle on this page, just again for thanking you for being here. We'll talk about it later. So also the jeffrog.com show notes is also on the bottom of every page. So obviously you can go there whenever you need to find something else. So with that, let's talk about software updates. I hope I convinced you that that we need to update faster. Obviously, you are not the only ones who got convinced. Also, Mark Reynolds. Mark Reynolds is the head of platform for Java in Oracle. He is one of the 2 most important people in the Java world, and he's the one who decided that Java also needs to be updated more frequently. Back 30 years ago, he decided that now Java will switch to 6-month release cycle instead of official 1.5 years, and not official de facto, everything between 2 and 5 years. So now Java is released every 6 months, no matter what. When Mark wrote this blog post, it was 2017, and the last official Java release was Java 8. So since then, they released Java 9, Java 10, Java 11, Java 12, Java 13, and if I'm not in error, Java 14 is about to be released, or maybe released already. So 6 or 7 versions have been released since then. Let's see how that works for them. So this is a result, this is a report from New Relic. New Relic are an APM company. They instrument Java virtual machines, so they know exactly which Java version runs in production for millions of JVMs that they instrument. You will be surprised, or maybe not, that currently more than 80% of production environments still run Java 8. That's the same Java 8 that was available in 2007 before 2017, before Java decided to move faster. And then you go like, what? Didn't we just say how important the updates are? How comes that no one wants to update their Java? And the answer to this question is in how we update, how our brain works, how we make the decisions when we need to decide whether we want to take a software update or not. So let's see how it works. Let's say update is available. We need to decide whether we want it or not. Sometimes we just don't want it. It's like, it's Java 9. There is nothing good about it. It's horrible. We don't want it. And then no, you don't take it. Sometimes we do want them. Let's say it's Java 12. Bunch of great features. We want them. The next question would be, are there any risks? If there are no risk in updating, sure, we will. We can try and update Java that runs on our local machine and try to play with new features because there is no risk. Worst case, it didn't work, we're all back and everything's fine. But obviously for our production systems, they are huge risks. And then the next question is, do we trust the update? Well, sometimes you do, and then you just go ahead and update. But unfortunately, it's very hard to even think about an example of software vendor that people trust blindly and just go ahead and update. I want to say JFrog, and we know a lot of customers that do exactly that trust us and go ahead and update, but probably some others won't trust us, and I guess the majority even, and they will do, and they won't update just because we have a new version. Then what? Then, if they don't trust us, the question is why? Why people don't trust software? One explanation is, well, people don't know how to do testing or QA. But this actually doesn't hold water, because if you have a Mac for a couple of years, you might remember how you used to trust Apple in terms of software updates. You had an update for operating system for macOS, and you have an important meeting or a talk in half an hour, and you're like, fuck it, why not? I will update it anyway because it will be fine. But not anymore. Whoever lived through the last major updates of macOS operating system knows that that's not the case anymore. And that's not because Apple forgot how to test. It's because things getting more and more complex. One of the examples of such a complexity is the interconnection between the artifacts and how we measure and look at artifacts. So it all started back in Agile 2000, when we actually started to care about the artifacts at all and do continuous integration and version the artifacts that we use and do this kind of stuff. And then continuous delivery. Every artifact becomes even more important because it is, in theory at least, can go all the way to production. And then infrastructure as code. Now we have hardware, which is related as software, and it obviously simplifies some things, but complicate others. Microservices, now we have tons of small artifacts that need to talk with each other and be versioned well and know how we can communicate with each other. And then Docker, every line of code is actually an artifact, a layer that we need to attend to. And then serverless, now every 3 lines of JavaScript code is an artifact that we need to attend to. And obviously IoT makes everything even more complex. Now my light bulbs here actually run Kubernetes or something. This is not make it things simpler. And it also not only the complexity of the code, it's actually the data. Data makes everything more complicated, not just because we might not predict how it behaves, but just because if we want to mimic now production environment in staging or pre-production, this is literally impossible, because no, it doesn't make any sense to invest the effort and to invest the money in creating production environment with this amount of data to simulate what's going on. So world becomes more complicated, and that means that sometimes the quality of the software is reduced, and this is why we don't trust our software. Now, if we don't trust our software or our vendors, the next question is, can we verify that it's good? Sometimes it doesn't make sense. So for example, for Java, if it released every 6 months and doing acceptance testing for all my production environments takes 6 months or more, I will just skip versions because I don't want to invest half a year just to verify something and discover the day after that there is something new that I want to take. So I will skip versions and I just want update. Or if I decide that I do want, then there is the time-consuming verification. And the time-consuming verification actually forces the vendors to put more food on the table. They want to add more compelling features to the update so the users will tend to do the verification and spend time and money to verify the update. And this actually makes a very painful trade-off for software vendors and for the users. So there are from one side, features that we really want. From the other side, it's the acceptance test code. So this game actually forces the vendors not only to not to update more frequently, but the other way around, to hold to the updates until they pack it with the features that they think the user want and release it only after. The problem is that the more seldom the updates, the more frightening it is to actually get them. So instead of having more acceptance rate for the updates, they actually get less. It's an impossible dilemma, and we can see if we can break it. So some companies try to, and the way they do it is update is available. Do we want it? It doesn't matter because we have auto update. So we will get it anyway. And it also works, only works for software which is low risk. For example, your browser. How many of you actually know which version of browser they're running? Chrome 85, Firefox 73. Those numbers doesn't mean anything. Chances are you don't even know what they are, or you for sure don't know what is the difference between Chrome 85 and Chrome 84. Because it's auto update, but also because there is low risk. Worst case scenario, something broke, it's unusable, you will use another browser for a day. Twitter in your browser, any web application, you have no idea what's going on there. You don't know which version it is, but frankly, again, it's low risk. What possibly could happen? You won't like the new user interface. Well, you get used to it. Twitter on your smartphone, again, most of the apps today in your smartphone are auto-updated. You have no idea which version is it. And if Netflix on your phone doesn't work, well, you will go and watch Hulu for a day. It's also not a big deal. High risk. Smartphone operating systems are not auto-update. They're not auto-update because they are high risk. So let's see why we are where we are. What we can do in order to rebuild the trust between the software vendors and the users. I will give you examples. The first example is Google on Hub. Google on Hub is the now 2 generations old router from Google. After that, we had the Google Wi-Fi, and now the Google Nest Wi-Fi. And one of the features which was really surprising and revolutionary back there was a self-improving system. A self-improving system actually means auto updates. Your router is sitting there, and without the painful procedure of firmware update, it's just getting better because new features are getting added. This is very cool. I bought this router for exactly that reason, because I like the concept. And then 3 years ago, February 2017, I was on a business trip and my wife calls me and she's like, Baruch, the kids are sitting in the dark. And I'm like, what happened? Do we have a power outage? And she's like, no, the internet is down and they are calling for our voice assistant. I don't want to tell her name because it will jump, but they call it for turn on the lights, nothing happens. So, well, on this day, the kids learned about the physical switches, but the internet was still down. So we call our vendor, we call our internet provider, and they're like, everything's fine. And then I get this email. And this email basically said, oops, sorry, we sent a software update to your router and it actually reset it to the factory settings. And now we don't have a way to fix it because we don't have an access to your router anymore. So please go ahead and manually reconfigure it. Well, to get this email, we need internet, but that's okay because I was on like hotel Wi-Fi or conference Wi-Fi. So I got this email and we got it working, but there are some lessons to learn from this. And the most important lesson is local rollback. Sometimes updates go so catastrophically wrong that over there patch cannot reach the device. That's exactly what happened. Now, in case of the Google Wi-Fi, it's not a big deal because there are people around those routers, they can always fix it and it's fine. Think about a solar panels array in the Sahara Desert. It takes 3 days in helicopters to get there and then 3 days more to ride camels to get to that. It's like a huge production loss until actually someone actually gets to it. So instead, we can implement a local rollback. We can have a previous version saved on the device and then we just roll back in case the problem occurred. Now, the funny thing about it is that we experienced the local rollback at least since Windows 95. If you're old enough to remember, this is how it looks like. You plug a new monitor or you replace a video card and then this pops up. Your resolution have been reconfigured. Can you see this message? If you can see this message, the update is successful, everything is fine. If you cannot see this message, and that's we cannot reach the local device, it will revert automatically because there is nothing else you can do. You don't see anything on the screen. You cannot change the resolution, so this is a local rollback. Since then, for some reason, we forgot how to do it, and that's a shame. Now you can say, well, you know, you talk about Wi-Fi routers, you talk about solar panels. This is all IoT. We don't really care about it. So why does it matter for us? Well, I will claim that the T in IoT is everything. And everything includes whatever you are working on your server-side development, your Kubernetes, your AWS, your Azure, whatever you work with is a part of the bigger game. And the patterns that we are talking about are actually applicable for each and every one of them. And talking about IoT, let's talk about updating cars. What can go wrong? And I will give you an example of a very, very nice electric car released last year called the Jaguar I-Pace. Jaguar I-Pace had a bug with their brakes, and that happened just half a year after the release. So it's a 2019 model, and by June, they discovered a bug in the brakes. Bug in the brakes is expensive, is important. So they had to do a recall, like a physical recall to get all the cars to the service to update the software and fix the bugs. And this is not the best way to do software updates because physical recalls are very costly, right? Think about all the service and structure that you need to do. And you cannot force an upgrade. If you ever had a recall on your car, you know how it works. They send you a mail, and then they might say to you a mail in the red envelope written in caps, but there is no way to actually enforce an update and make you go to the service and do what's needed to be done. Obviously, over-the-air software updates is the way to go because then it's cheap and you can force an update whenever you like. Now, software updates are good. The only thing better than software updates are continuous software updates, over-the-air software updates. And I'll give you an example for that from another great car. Tesla knows how to update their software over the air. You probably know that. I'll give you an example of where they can do better. So for example, there is this issue that it's called phantom braking. Phantom braking is basically the car drives on autopilot on a clear sunny day, there are no obstacles, and boom, suddenly the car slams on the brakes. Not only this is very annoying, there is actually no way in the world you can convince your wife and your kids that you didn't do it, that it was the autopilot. They will blame you, and that will be at least very awkward and uncomfortable. So there is a rumor that the phantom braking is going to get much better. It will be solved. And then you wait for an update, you wait a day, a week, 2 weeks, and the update doesn't come. And when it comes, you look at the show notes, and it turns out that you were looking for chess, right? Those minor improvements and bug fixes are actually the fix for the phantom braking, but it wasn't released because the engineers were working on chess. And as I already mentioned, today vendors try to group those updates to something that will be very lucrative to the people to force them updates. Now, with Tesla, it doesn't make sense because in Tesla, you don't actually can choose to skip versions or not to update. Tesla can force you software updates, and this is great. Now, why they group important features with not important features, it's an open question. And we with JFrog actually working to change that. So the funny part of this particular case is that what is important is in the eye of the beholder. Think about it. I like the new shiny toys. I'm on the latest version of updates. I definitely use the autopilot. I enjoy those things, and I don't play chess. For me, the fix for autopilot, for the phantom braking, is way more important than chess. There are smart people who play chess and don't trust autopilot. For them, it's the other way around. They don't care about the fix for phantom braking, and if this is what holds back the release of the chess, they will be really annoyed. So whatever it is, however you look at what's important and what's not, the problem with bulk updates is that important features wait for not important features. And the only way to overcome it is implementing continuous updates. You have a feature, release it. You have chess, release it. You have a fix for phantom braking, release it. And especially with Tesla, who don't ask the drivers, but push the software updates to the cars, it actually makes even less sense to batch, to group updates together. So by now you can say, okay, this is not relevant. I'm not a Tesla engineer. I'm not an IoT engineer at all. I work on backend. Why does it matter? And I want to tell you that if you think that your problems in software updates are hard, well, comparing to the IoT, mobile, automotive, and edge, your life is very simple and very convenient. You control the availability of the target, they don't. You control the state of the target, they don't. You control which version, you know at least which version exists on the target, they don't. And you have access to the target all of the time, most of the time, they don't. So basically, your life is much easier than theirs. And still, even considering all that, we, the server-side engineers who update services on our data centers or the cloud that we control, manage to fuck up royally. The best example is the Night Capital. And that's an old story, 8 years by now, but this is legendary. So if you never heard about it, now you know. Knight Capital was a trading firm on Nasdaq with New York Stock Exchange with automatic trading, and they had a platform that were trading in that they traded $440 million, one of the biggest firms that do that. And then they decided to update their system. Now, the problem was that they didn't do it for like 8 years. It was first updated many, many years. And one of the things they decided is that they're going to reuse some old APIs, old flags, old state to make it easier for clients to migrate. And then they just forgot to update one of the 8 servers in the cluster. And that means that some of the new clients send requests to the machine containing old code, and whatever APIs they used did something completely different, like sell instead of buy, buy instead of sell, something that will cause them losing tons of money. And then obviously they see that and they panic. And what they do is they undeploy the working code from those machines, from the updated machines, or they turn down the updated machines because something went wrong with that update, right? And then 100% of the requests go to the wrong code, and obviously the losses are enormous. They lose $1 million every second after, sorry, $10 million every second after, no, $10 million every minute. And after 40 minutes of debugging, when they actually find what the problem is, they are out of business. They are just, they never recovered from that. They had no monitoring, no alerting, no debugging, everything manually, and it was a really disaster. So what can we learn from that? A lot. First of all, automatic deployment. People suck at repetitive tasks. Once you automate everything, you cannot just forget to update one of the servers. The second, frequent updates. If you do updates seldomly, you don't know how to do it. And if you know, you are still very, very nervous and very anxious to do that. Solution, updating frequently, develop skill and habit. And as the saying goes, if it hurts, do it more. State awareness. You need to do what you are doing. If you decided to reuse old state, you need to understand the consequences. Also for reverting, if you decided that you need to roll back, be aware that the clients already use the new functionality, so will it work after that? Another great example is what happened to Cloudflare just less than a year ago, in July, almost a year ago, July 19. If you might remember how Cloudflare took half of the internet with them, let's see what happened there. So Cloudflare deployed new rules to fight DDoS attacks. So they have routing rules that help to mitigate it. Those routing rules are are deployed on a regular basis. And what happened this time is that they deployed one misconfigured rule. Now, today, after what happened with Cloudflare, I'm absolutely sure that this world is not going to die of coronavirus, meteorite, global warming, or a nuclear war. It will be a regular expression, single regular expression that will destroy the humanity. And that's exactly what happened to CloudDark. This misconfigured rule contained a regex that managed to spike the CPU 100%, and then obviously it spiked the CPU of the entire cluster to 100%. And basically, next thing we know, when you look at Cloudflare status page, affected region Earth. So, sense of humor, we give them that. Let's see what went wrong. First of all, releasing a bug affects all the users. So you can use stuff like canary deployment, progressive delivery to release to a small number of users first. And by that, you reduce the blast radius. You reduce how many people will be affected if something went wrong. And then you observe, and if a problem occurs, you stop the release, you revert, or update the affected. Now, this concept being with us forever. You probably learned about progressive delivery when you were about like 8, when you learned how to do laundry, because on every detergent or fabric treatment chemical, you will see this warning. Always spot test on a hidden service first. Spot test is progressive delivery. Again, for some reason, we forgot this skill when we came to updating software, and it's time for us to learn it anew. Observability. Some problems are hard to trace, relying on user feedback only. Watching the Twitter for angry tweets is probably not the best way to troubleshoot your software. Instead, you implement observability, the 3 pillars of observability: tracing, monitoring, and logging, and you teach your system to automatically at least determine that there is a problem and hopefully also roll it back. Talking about roll it back, fixes might take time and users suffer in the meanwhile. Instead of waiting for a fix, roll it back to a previous version. If it is possible, sometimes there are platforms in which rollbacks are not supported. For example, both mobile application platforms, both the Google Play and Apple App Store, do not support rollbacks at all. Even if you take the same artifact that was in production yesterday, you cannot just say, okay, that's the same artifact, you already tested it, just put it back because new one has a problem. No, you need to reversion it to a next one, submit it to review again, wait for it to get approved, and only then you can put it in production. And during all this time, people suffer from a bug that you released. So instead, you can think about stuff like feature flags. You can embed 2 versions of the features in the app, or at least a way to disable new feature in the app, and then you can trigger them through API on the customers that actually suffer from a bug or something that you missed. And the last one that I want to mention is MoviePass. You probably remember again, mid last year, MoviePass went down for several weeks to update the app. Now, you understand how ridiculous it is. Our goal is to release as fast as possible and having 0 downtime updates. And obviously, if you release, if the release takes you 4 weeks of downtime, when you come back, you'll probably have no customers at all. That's exactly what happened to MoviePass. They never recovered from this 5 weeks of application update. And then obviously when they came back, there is no one there. So instead, implement the 0 downtime, over there, small and frequent continuous updates. So to summarize, continuous updates are frequent, automatic, tested, progressively delivered, state aware, observable, and implement local rollbacks. That's kind of extra credit task, but again, not something unheard of. And if you really need them, you really need them. So what we want to get in the end is update available. Do we want it? It doesn't matter. Are there high risks? It doesn't matter. We will update either way because now we actually trust the vendor because we know they do continuous updates well enough, and it means that we are covered and we can update whenever the update is available, which is almost all the time. Our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates, so tiny and so frequent that they provide an illusion of software flowing from development to the update target. We call it the liquid software vision. And that's a quote from one of the authors of the liquid software book, from Fred Simon, who describes what liquid software is. This book is written by 2 co-founders of JFrog, Fred Simon and Yoav Langman, and yours truly. And we go in details about what it is. This you already know after today, but also how to do it. And we cannot stop throwing more and more gifts and presents on you. So if you go to my Twitter and send me your shipping address in the direct messages on Twitter, I will ship you a physical copy of the Liquid Software book for free, just for thanking you for being here. So more prizes for being here today. Now let's take just a couple of more minutes to talk about corner cases. You probably thought about, well, this is nice, but obviously there are some cases in which we don't want to get opted automatically. And the user cases are, we kind of assume they're about 10%, and they are actually of two types: user control and user and update priority. You can say, okay, I cannot allow this update to happen because, for example, I'm in the middle of a flight on a plane. Do I want to update my plane mid-flight? And you know what? I bet most of you don't think that updating a plane mid-flight is a good idea. And I will take a minute to try and convince you otherwise. For that, I will use two examples. One of them is memory leak on Airbus 350. So Airbus 350 has to be rebooted every 150 hours because they have a memory leak, and if they don't, some systems are just stuck. And if you think, well, I will never fly Airbus again, I prefer Boeing. First of all, you already know about the software quality on Boeing with everything that happened with 373 MAX, but 73, you know what I mean? To add on that, 787, the best plane that Boeing ever did so far, has a register leak. And this one has to be restarted every 31 days to prevent misleading data being shown to the pilot. So there are bugs in software everywhere. And now think about it. You are flying. You remember those days when we were flying in the planes, in the sky, like birds. It was like magic. Remember those days? So you are now in the route from Los Angeles to Tokyo. And you passed Hawaii, and there's some time to go to the nearest airport. And then the co-pilot asked the pilot, "Did we reboot the plane this morning?" And the pilot now, "Oh, we forgot." And the co-pilot now, "Well, our 150 hours is almost out. What do we do?" Wasn't it be nice so we can patch the plane mid-flight and fix this security leak? I bet this is where you think where it might be not a bad idea, but how it's even possible to debug and patch the plane mid-flight? Well, this has been done long time ago. 777 was the first plane that was driven by software, completely by software, instead of the combination of software and physical hardware switches. 777 installed software, including the turbulence controls. So turbulence controls try to minimize the shaking during turbulence, and it didn't work very well for them. So what they did, they put all the R&D on the plane. They took off. They went to a place where there was turbulence, debugged the plane mid-flight, and actually patched it mid-flight. So it is possible, and I would argue that when we come to a point when we trust our software vendors, that patching plane mid-flight to battle some critical bug, or maybe someone tries to hijack the plane using software, it's actually a very, very good idea. So with that, Twitter ads. I'm at JBaruch on Twitter. Liquid Software is the hashtag for talking about the book. Nash DevOps, I guess it's the hashtag for this group. I don't know, just an educated guess. liquidsoftware.com, this is where you go to learn more about the book. As I mentioned, go to my DMs on Twitter, drop me your shipping address. You will get the book for free. And JBaruch.com/show notes, this is where you find the links, all the links, the slides, hopefully the video soon. And as Ari already mentioned, the raffle, one of two Nintendo Switch Lites, more goods coming your way. Just go there, participate in the raffle, and win that as well. So this is all for me. Thank you very much. Now I think it will be a good time for questions. And I think you can just unmute yourself and just ask away. Or we can just go and do something else. I guess it's almost 5 o'clock in Nashville, so drinks. I'm in the bar, so I'm good.
That was a good presentation. Thank you.
Thank you. Appreciate it.
Yeah, well, if there's no questions, then yeah, thanks guys for presenting today. That was excellent. We did record it, so we'll be posting that on YouTube in the next.
If you can just drop me the link for YouTube, I will add it to the show notes as well.
Yeah, absolutely.
Perfect. All right. So thank you very much again. And I hope to see you in person very soon. Steve, sign me up for the next in-person meetup we have.
Absolutely. Well,
All
thanks
right.
again.
Thanks, guys.
To everyone for joining. Thanks again to the JFrog guys for being here. Be on the lookout for the next meetup, everyone. And yeah, I'll include all this information, contact information as well. So if you want to reach out to the guys, you can do that on your own. But thanks again, everyone. Looking forward to the next one. Hope everyone has a great evening.
Take care.
Sounds good. Thank you.
Hey, guys.
Bye-bye.